Welcome to this session, focused on how at AXA we use AWS technologies in order to accelerate our innovation and to ease the maintenance of our connected car pipeline. My name is Vincent Héribarin. I'm a technical leader at AXA Group Operation, and I'm with Xavier Lou, Principal Solution Architect at AWS. Together, we will tell you how we transform our legacy telematics project into a serverless one so you can do the same thing. You will learn about the AXA Techs project and more generally about telematics. You will have some insights on our first platform version, which was infrastructure as a service oriented, and some issues we had with it. That's why we decided to transform it to a serverless project. At the end, I will share with you some lessons we learned while doing this transformation. Before going further, let me set up some context. So I work at AXA. We are a multinational insurance company. We do asset management, life and savings, and also property and casualty insurance. More specifically, in our case, we do car insurance. We are deployed in more than 50 countries, and more specifically also in Europe, where our project takes place. I'm part of AXA Group Operation, and more specifically in the Emerging Technology and Data Division, which is an innovation division. So there we test new technologies, new algorithms in order to create new kind of insurance products. There you will find the telematics team. That's us, 6 years in business, and there we use data science to transform automotive data. And the project I want to talk about is called TEX. TEX for Telematics Exchange Platform. Currently, the way people use cars is changing. We've all heard about autonomous cars. They're not there yet, but they're coming. Car sharing platforms also encounter some huge successes. So there is a need to create a new kind of insurance products. Our platform enables pay-as-you-drive and pay-how-you-drive kind of insurances. So with them, your premium can be adjusted depending on the way you drive. We can also provide some feedbacks at the end of your trips so you can drive better. It completely changes the way someone can experience his car insurance. Our platform currently manages more than 60,000 trips per day for about 40,000 customers. Those figures are steadily growing. How do we do that? First of all, we collect data from natively connected cars. If your car is not connected yet, we can also use some boxes that we put on your car battery or sometimes on the diagnostic port of your car. Some projects can also use simple smartphones. We also gather contextual information like the weather, cartography, road traffic. So we get all of that, we process them, and we compute a driving score. This driving score is then exposed to AXA entities or to partners which manage new kind of insurances. The platform processes the data as it comes, so we can provide some quick feedbacks to users. In our first platform version, we did that using EC2 instances. We had something like more than 50 EC2 instances split in various environments, and it was fully designed to be ported back in AXA data centers. That's why we use very few AWS technologies. Apart from EC2 instances, we only use elastic load balancers. We manage all the monitoring parts using tools like Shinken, Grafana, Kibana. And globally, it was using lots of open source tools like Kafka or Elasticsearch. We use Python as a kind of common language between data scientists and backend developers. Unfortunately, it became quite difficult to manage this architecture. We had to update the operating systems quite frequently. It became more and more difficult to add new components because it was complex to deploy. And we even had some strong security issues. For the story, we had to deploy some IPsec links between all the nodes, so even AWS could not see what was happening on the platform. So we needed to change that. We wanted to change that to do less system engineering. We are a tiny team. We cannot afford to manage some operating system issues. So we wanted to do less system engineering. We wanted also to scale more and more easily. Actually, our platform could scale, but we had to manually add some nodes since we were not using, for instance, auto-scaling technologies coming from AWS. We also needed more securities. Actually, we manage personally identifiable information, and we have strong security constraints, strong legal constraints, and we simply want an easier way to manage this information in a secure way. And finally, we wanted to focus more on features because came a time where we spent more time in managing the platform rather than adding some new features. So 2 years ago, we decided to change this platform. And since at AXA, the policy evolved so more cloud services could be used, it was a perfect moment to try another approach. So we started to discuss with AWS to study what we could do. And I think it's time for Xavier to tell you more about this story.
Thank you, Vincent. The AXA TEX project team was thinking they could address the challenges of TEX v1 using a better architecture. They were interested in serverless, but they were not sure that it could be a good fit for their project. So they contacted AWS, and together we decided to work on a target architecture. We organized a workshop to understand their challenges, their goals, and to be able to do recommendations. We wanted to see if they could replace their existing components deployed on EC2 by AWS serverless services. The main challenge of TEX v1 was that the project team was spending too much time on the undifferentiated infrastructure heavy lifting. That was slowing their capacity to innovate. AWS helps reduce the amount of infrastructure tasks you have to do. However, depending on the service, AWS will take more or less responsibility. Let's take the example of compute. If a customer chooses to use EC2 instances, he will be responsible for provisioning, scaling, patching, securing, connecting the instance. At the opposite, if a customer uses Lambda, he will only be in charge of his application code. Lambda is fully serverless, and all the infrastructure is abstracted. And between IaaS and Lambda, you have other managed services like Beanstalk, where the responsibility is more balanced between AWS and the customer. This is the same for messaging services, where you have the choice between deploying service on IaaS or use an abstracted service. And you have the same choices again for the databases, relational or NoSQL. TEX v1 was not using any AWS managed service because at the beginning, AXA wanted to ensure the application could also run on-premise. That created a lot of operational burden for the team of TEX v1. But in 2017, AXA built a new move to cloud strategy, allowing the usage of AWS managed services. So together, with the TEX team, we analyzed how to improve TEX architecture by replacing existing components with more abstract ones. Let's start with compute. The AXA-TEX project wanted to use serverless instead of EC2 VMs. However, they were not sure if they could use Lambda or if they needed containers. So we looked deeper at the workload's requirements. Most of the compute was asynchronous processing of the events sent by the connected cars. For this need, Lambda is a very good fit. It offers a great scalability, cost is optimized with no unused resources, and moreover, Lambda is well integrated with the other AWS services, especially Kinesis for streaming. This was around 90% of the compute task. However, there were some use cases which were not possible with Lambda, like the communication with some telematics boxes, which required UDP, or long batches. For these use cases, they decided to use Fargate, a serverless compute engine for containers. With Fargate, they were able to get the flexibility of containers, but without the need to manage the instances. At the end, the target for compute was Lambda and container. For messaging, event streaming, we also wanted to replace Kafka on EC2 by more abstracted services. So we analyzed the business needs. The service had to manage a minimum of 1,000 car events per second. Each event could have multiple consumers, and there was a need to preserve order. Taking into account these requirements, Kinesis was clearly the right solution, as it is designed to manage event streams. It provides great scalability, it's able to ingest millions of events per second, and it is possible to batch read events to optimize performance and costs. For the project, there was also a need for simpler queues to process the driver score. And for this need, we decided to use SQS, which is even simpler to manage than Kinesis, because you do not need to manage shards. So for the messaging and event streaming services, we were also able to abstract most of the infrastructure heavy lifting. We did the same exercise for the databases. At the beginning, the team was not sure if they should use SQL or NoSQL. And once again, we had to deep dive on the business requirements. For the current trip data, TEX needed to scale to store a lot of events. The requests were mostly key value searches, and data did not need to be persisted after the trip had been analyzed. DynamoDB provided many benefits for this use case. It's fully serverless, no management task, pay-per-use billing. It scales horizontally, offering high throughput and fast ingestion of data. And the time to leave features makes it possible to automatically remove all trips data. For the other types of data, the project needed to do more complex requests with table joins. So the team chose to use Aurora PostgreSQL. And they decided to use Aurora serverless to minimize the infrastructure tasks and to be able to have automatic scaling. So once again, they had a pragmatic approach. They used both SQL and NoSQL, the right tool for the right job. TEX v1 was only using IaaS. At the end of the architecture workshops, we had defined a new target for TEX v2, and the new architecture was leveraging AWS serverless services to help the team focus on features. I will now let Vincent present the full target architecture.
And you can see here the result. It's a part of the platform, but it's a complete project. Some parts are shared between projects and some others are very specific to projects. Let's have a deeper look. First of all, we have the ingestion part. There, we collect automotive data. Typically, it's a part that really depends on the project. Here, we are in a case where we fetch data from a car manufacturer. But with some other projects, we have data which is pushed to us. So here, we have a CloudWatch events which trigger some Lambda. And those Lambda simply fetch data from a car manufacturer database. This data is then stored in a S3 bucket to be archived and for further processing. Then comes the processing steps. So here we transform the data up to the point we can compute a driving score. We transport the data using Kinesis when it is not stored in the database yet. But once it's stored in the database, we simply use SQS to carry simple processing orders. I want to focus a little bit on our driving score algorithm because at the beginning, we feared it might not be possible to use a serverless technology because we use Python to compute our driving score, and some Python libraries can take lots of places, and there are some size limits with Lambda. Fortunately, AWS created a Lambda layer optimized for data science, and we managed to use this layer to set up our driving score. We then have the enrichment part. Well, actually, this step is used before computing a driving score. And there we enrich data using contextual information like the weather, road traffic, and cartography. Since it's a service that can be used by other parts of our platform, we expose it using an API gateway, so it's a kind of microservice. You can also observe that we use Amazon Elasticache. That's not a serverless service. It's a managed one. But in our case, it proved to be more interesting to use than DynamoDB, so we do not hesitate to have a mix between serverless technologies and managed services. Once we have full trips and once we have computed a driving score, we store all of that in our persistence layer, which is essentially, which does use an Aurora serverless database. And we expose this result to Axe entities simply through an API gateway. Here the figure is simplified, but we also use other technologies like Amazon Certificate Manager to manage our TLS certificate, or also Cognito to manage our OAuth authentication. We also deployed a data lake for data scientists. Here we store our data in S3 buckets, and we use tools like Athena or EMR to explore the data. And finally, our supervision and monitoring part. So in our first platform version, we had to set up all the log collection, all the monitoring. We have to maintain all of that. It was quite a hassle. But with serverless technologies, it basically comes out of the box. We have nothing to do. Data automatically flow to CloudWatch logs, and currently, CloudWatch dashboards are enough for monitoring needs. We also use Secret Manager and Parameter Store to store configuration and third-party secrets that I use to connect to third-party services, like to get the weather from an external server. And to prove you that this architecture is well suited for our needs, I have some CloudWatch graphs to show you that. At the top, in green, the incoming traffic from cars. At the bottom, how all of our Lambda reacts to this traffic. Lots of traffic the day, lots of Lambda activities. Less traffic the night, less Lambda activities. And if we focus on a specific Lambda, which is our enricher, on the right, you can observe in blue that the day we have more multiple concurrent execution of the Lambda, so there is no delay in our pipeline. There are two side effects to that. The first one, if we have no traffic, we pay nothing for the busness logic. Of course, we have other costs, like data storage or periodical jobs that we may launch, but it's $0 for our business logic when there are no traffic. And so if you need to deploy other environments, like for pre-production, UAT, it helps to pay less if you have less traffic than in production. We also changed the way we organize our AWS accounts. All of our accounts are placed in what we call the AXA landing zone. It's a concept that was presented in a previous reInvent session. I think you may find the video on YouTube if you want to know more about that. This AXA organization deploys some SCP to all of our accounts and also allows centralized billing. Then in our accounts, we have a special stack, an AXA Foundation stack, which is deployed in there, so security and audit can be enforced, and also compliance rules. So for instance, it simply configures tools like GuardDuty, CloudTrace, or AWS config. Then we decided to dedicate several AWS accounts for all of our variants of our platforms. So we have one platform for production, another for pre-production, another for integration, and each developer has his own account, so he can test things without breaking anything in production. We also have a dedicated analytics account for data scientists. From there, they can explore the data in production and in read-only mode without disturbing our production. And finally, we have a tools account. Actually, it's our continuous integration, continuous deployment base. From there, we build our artifacts using Jenkins. We store them using S3, and we deploy them using Terraform. In this account, we can also host some shared services like DNS management or centralized authentication for administrative purpose. So, did we succeed in resolving our issues? Yes. We do not think anymore about system engineering. The remaining place is on database, where we have sometimes to tune things, but it was already something which was a shared responsibility between a system engineer and a software engineer. We also scale more easily, since we only use scalable components that can scale, like Kinesis or Lambda. Some components may need manual tuning, though, like Kinesis. We also have a more secure project. For the story, in our previous pen test, we only had business logic issues, whereas in our first platform, we also had to deal with operating system level issues, virtual machine level issues. So a whole class of issues simply disappeared thanks to serverless technologies. And finally, we can focus more on features because we spend less time in managing our infrastructure and we are more comfortable in deploying new components. As a conclusion, I would like to share with you some lessons we learned so you can avoid some mistakes we made, also you correctly understand the serverless usage. First of all, serverless does not mean zero configuration. As an example, with Aurora Serverless, you still need to set up a VPC and to configure an IP addressing plan. Also, with Kinesis, you also have to tune the number of shards you need. Then, the technology maturity is not the same between components. For instance, with Aurora Serverless, you will have less features than with its non-serverless counterpart. As an example, and as of today, Performance Insight is not available with Amazon Serverless, or it's more difficult to do export and import from S3 buckets. But things can evolve quite quickly with AWS, so I'm sure there will be some upgrades in the near future to fix all of that. You should also think about having an hybrid architecture. Full serverless is not always possible, and in our case, we have a mix of serverless technologies, managed technologies, and also containers in some very specific cases. So you should keep that in mind and take that into account in your infrastructure as code. And finally, beware of automatic scaling, because for the story, we had a scaling issue with Lambda and our business logic. Due to a bug, our architecture simply scaled too much and we paid far more than usual. So please, set up alerts, set up limits, and currently you can even set up some daily budget limits, alerts, so please, configure them, use them. That's it, and before closing this session, I would like to thank you all the team who contributed to the project. And if you wonder about our next steps, it's simply to add new features and to tune things while AWS also updates its technologies. Actually, our main technology work is on our CI/CD pipeline, which use a more traditional approach than a serverless one. So it's a topic by itself, but we'll have to work on it. Thanks for watching. Don't hesitate to share. And please, take some time to complete the session survey. Goodbye.